everybody. Today we're going to review how to write an equation of a line. A line can be written in three forms. The way that you're probably most familiar with is slope-intercept form. Slope-intercept form is written y equals mx plus b. If you remember, the m stands for slope and the b stands for y-intercept. The next form of a line, which is often more convenient to get started with, is point slope. So point slope just has a point and slope in it. Y minus y1 equals m times x minus x1. So here the m still stands for slope, and x1, y1 is just any point on the line. So if you're given the slope and a point, this form is very convenient to write the equation in. Now the next way is standard. Standard form is written ax plus by equals c. Here a, b, and c don't stand for anything in particular that you can see on the graph of the line. However, a, b, and c must be integers, and a must be positive. So let's try an example. Let's try to write the equation of a line that has a slope of 1/2 and a y-intercept of -5. So now if I'm given the slope and a y-intercept, it's easy to write the equation of a line in slope-intercept form. So that was the first way that we talked about, y equals mx plus b. So because I have the slope and the intercept, all I have to do is plug it in. My slope is 1/2, and my y-intercept is -5. If you prefer to write this as just -5, I think that that's better, but I'll accept plus -5 as well. So now, the next portion of this question asks you to rewrite this in standard form. Now, if you remember, standard form has the x and the y on the same side, and all the coefficients, or the numbers in front of the variables, must be positive. So let's start with what we have here. And if I want to get the x and the y on the same side, then I have to bring the a to the left. So in order to do that, I'm going to subtract 1/2 x from both sides. So I get -1/2 x plus y equals -5. At this point, I want to decide what number I should multiply the whole equation by in order to eliminate all of the fractions. You do that by finding the common denominator between all the fractions in the problem. Here I only have one fraction, so the common denominator is 2. I also would like to get rid of this negative, so I'm going to multiply by a -2. If you want to do this in 2 steps, first multiply by 2, and then multiply by -1, that's okay too. So I'm going to make that -2 go through to everything in the equation. So -2 times -1/2 is just 1, so I just have x. -2 times y is -2y, and -2 times -5 is 10. Now I have achieved the 3 things that I wanted to get an equation in standard form. The first thing is that the x and the y are on the same side. The second thing is that all of the coefficients, a, b, and c, are integers. And the third thing is that the number in front of the x is positive. Here there's no number there, but it's assumed to be a 1. Now let's try to write the equation of a line with a slope of 3 that goes through the point 5, 9. Now here, it's easy to write this equation in point-slope form because we're given a point and we're given the slope. So if you recall, point-slope form is y minus y1 equals m times x minus x1, where m represents the slope and x1 and y1 represent any point on the line. That point that's given to you will be that point. So I just fill everything in. y minus y1 is the y value from the point that I was given, which here is 9 from this. Then I write the slope that I was given, 3, and then x minus the x value of the point that was given. So here we have an equation in point-slope form. Now the next step says to rewrite the equation in slope-intercept form. All that means is to get the equation in the form y equals mx plus b. So I'm starting with y minus 9 equals 3 times x minus 5. If I want to get the y alone in the equation, and get this distributed the way it is, I'm first going to distribute the 3. So I get y minus 9 equals 3x minus 15. After taking that step, I'm just going to get the 9 to the other side by adding it. So I get y equals 3x minus 6. Now I'm in the form y equals mx plus b. If you notice, the m in this form is 3, which was also the m in this form. It's the same line, just written in a different way. So just to be clear, if I went to graph this line, I would get the same result. Here, when I'm using point-slope form, I want to start at the point 5, 9, and then I want to use my slope of 3. So I go up 3 over 1, up 3 over 1. Then I also need to go down 3 to the left 1, down 3 and to the left 1, down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. If you notice here, my y-intercept is still negative 6, which is what we found when we graphed it this way. Same line. Now let's try a more difficult example. Here I want to write the equation that goes through 2 points, the point 6, 2, and then point 5, negative 1. And the direction setting can go in any form that I want. If I'm given 2 points, it's always easiest to go in point-slope form. But here I'm not given a slope. So the first thing you have to do is find the slope. If you recall from Algebra 1, the formula for slope is y2 minus y1 over x2 minus x1. Here, x1, y1 represent a point, and x2, y2 represents another point. So if I want to figure out the slope of this line, I just plug these values for x and y into the slope equation. So here y2 is negative 1 and y1 is 2. Then x2 is 5 and x1 is 6. If I complete this calculation, I get that negative 1 minus 2 is negative 3 and 5 minus 6 is negative 1. That leaves me with a slope of 3. Now that I know my slope, it's very easy to put the equation into point-slope form. I have a point, I actually have 2 points, I can pick either one that I want, and I have the slope. So let's pick this point, just because it's the first one, it doesn't matter which one you pick. So now, according to point-slope form, I'm just going to plug everything in. So y minus, my y1 is the y value of the point I was given, which is 2. Then the m here is 3, what I found up here. And I have x minus x1, which was the x value of the point that I'm going to use. So now I have the form, the equation of the line in point-slope form. It's also totally the same thing, totally appropriate to use this other point instead. If I did that, the equation would be y minus negative 1, which would be plus 1, equals 3 times x minus 5. Either answer would be totally acceptable and be the same thing. Thank you for watching the video. Please don't forget to answer the questions.